Hello dear students, today we continue discussing the properties of demand and supply curves and specifically some operations on the demand and supply plane with respect to curves, movements along the curves and shifts on the curves, focusing on the demand curve primarily. We'll discuss the properties of market equilibrium and do some exercises that will be related to your exam performance. What you'll do as exam will be suggested to you with exercises today. So today is a very important seminar. It's teaching week number 3. Let's start. In the past teaching week, we discussed the properties of demand and supply curves in the sense of explaining why the demand curve is downward sloping and the supply curve is increasing. To support the idea that the demand curve should be the downward sloping one, usually I use that idea of ratios of marginal utilities to prices whenever you optimize consumption at the margin, so to speak, for the last item to be put into your consumption basket. Remember, we had consumption basket, and we were considering which items to consume and in which order. This first, should it be consumed first? This item, should it be confused as the second one? Question mark, or maybe the first one. The order of consumption is determined by the marginal utility to price ratios. You always opt for an item that has the highest marginal utility to price ratio. That ratio, right? That should be the highest for the item to be put next into the consumption basket. So with these prices for bowling and movies, you go in that order, optimizing consuming items on the free day. Remember, we had a choice between movies and the bowling. So you went from the highest to the second highest to the next, to the next, to the next, and to the next. To the next high, so always just as you consume more of any particular item, its marginal utility to price ratio declines due to the principle of the diminishing marginal utility, right? The principle of diminishing marginal utility drives the numerator of that ratio. Using the ratio itself to decline, the price held constant, it's constant, right? So the ratio declines as you move down the consumption schedule. So whenever you decide what to consume next, you will have the ratio as if estimated in your mind. You don't do it consciously, but probably you do it subconsciously, as I explained to you in the past week. Economists believe that you don't do it consciously, because only economists know about the ratios and the math involving them. But subconsciously, that seems like what the consumers are behaving, again with many exceptions. And this income effect is something I want you to refresh in your mind for today, because we are going to deal with that extensively. Let's see what happens if you change the price for consumption from given the same budget constraint for your cash in pocket. You change now your price for movies from the low to the high one. You cannot consume the fourth item of this and the fourth item of that. So your consumption will be just limited to 3 items. Okay, just to 3, because after consuming 3 of this and 3 of this, you exhaust your budget constraint, $36 are spent, and that was your original endowment for cash. Okay, so what you did with that original endowment for cash and that price for movies, you went consuming first that item, then that item, then you were indifferent between these two, and also indifferent between these two. Out of sudden, then what happens? The income effect happens. Let's have our movie price dropping from $8 to $5. Okay. Just 5 for the time being. From 8 to 5, it went down. What happens? You now, after having consumed 3 of these items and 3 of these items, you can consume more. You can still continue consuming because you don't yet exhaust the entirety of your budget constraint. Okay, again, how and in which order to consume after having spent $27 is determined by the ratio of marginal utilities to prices. If these ratios are like that, 1 for movies and 3.75 for bowling, see what happens. Of course, after having spent $27 and having the movie price decrease, go down from $8 to $5, you seem to be optimizing what is to consume next after having consumed 3 items of this and 3 items of this. You seem to be considering what to consume next according again to the principle, choosing the next best utility. And it seems to be the bowling item that has the next best utility. So you opt for that as a seventh item in your consumption basket, the seventh one, right? 3 of this plus 3 of this, and now you opt for one extra. That will be your fourth item in line here. And notice what happened. It was the price of movies that declined, but you didn't end up consuming more of movies. You ended up consuming more of bowling. Okay, so income effect is like that. It's the movie thing that went down in price. But in association with that, you didn't consume more of movies. You actually ended up consuming more of bowling. It's a cross effect between the goods. It works across, right? Across. It's a cross effect, usually. The price for one item went down, but you ended up consuming just not the item itself as a next consumption item in your consumption basket, but you opted for bowling, to consume more bowling, just given the schedule of total utilities and the associated marginal utilities. It so happened. Remember also that case of a Griffin good called the potato, the Irish famine potato. After the Irish famines in 19th century, 1944, the price of potato went down, of course, and under a normal situation, you would have expected your consumers to consume more of potatoes. The price of potato is less, so you consume more. That, of course, didn't happen. What happened is the income effect came into play. The price of one good declined, the price of potato declined, right? And it was such a staple item, just claiming the majority of your food budget, just everything. In a famine situation, you just spent everything on food, whatever you had, right? And after the famine ended, the price of potato declined. So you ended up having to spend less on potato, and you freed up lots of cash. So you ended up not spending money on potato, actually. You ended up, with its price declining, you ended up consuming more quality food, the meat, the bread. So you substituted potato consumption with the quality food. The income effect came into play for potatoes, right? The price of them declined, but it ended affecting the consumption of meat. You consumed more of meat. So there's a cross interaction between different markets. See, this income effect is a first thing that, like we're introducing, that to show that there are plentiful interactions between different markets. For normal goods, inferior goods. For normal goods, the demand curve is the normal one, is downward sloping one, right? It's a downward sloping one. The lesser the price, the more quantity is demanded. The higher the price, the less quantity is demanded. For inferior goods, it's inverted. So instead of having the normal demand curve, not that thing anymore, but you have the inverted demand curve. It's a cross effect, right? Because extra income, the money freed up, goes not on consuming the inferior good. It goes up towards consuming rather meat, a more quality good in that famine situation. First cross effect was introduced to you, that's the income effect. Today we'll have some other cross effect explorations. One market is shifting, but something else happens on another market. We'll discuss such interactions, repercussions, what have you. And let's start now with one thing about interactions. So today we're discussing interactions, the idea that the demand and supply curves can be used to describe interactions and changes on a market. And let's start with that situation. But pretty much you can analyze demand and supply, right, in that price and quantity space. So when you analyze the market in its own terms, we have two axes, one for price, right? One for price and one for quantity, two axes. And analyzing market in its own terms, so to speak, involves just analyzing these factors internal to the market, the price and the quantity. So we have internal factors, right, which are just two factors when we analyze market in its own terms, internal. You have price and quantity being your internal terms of market analysis. Price reduces the quantity of good consumed normally for a normal good, not the inferior one, but the normal one. The price is less, consumption is higher. The price is more, consumption is less. The downward sloping demand curve, right? This is a normal analysis for demand on its own terms, in terms of P's and Q's. And this is internal analysis. You analyze only two parameters, two axes, two internal parameters. That's it. The list of internal parameters analyzed with this two-dimensional chart is just exhausted by two parameters, the price and the quantity. But of course, markets are impacted by all sorts of developments in external circumstances. So external circumstances, there are plenty of them. The previous slide actually concerns such circumstances, and let's just review those circumstances. Apart from analyzing market for changes in its own terms for P's and Q's, that's plethora of these external circumstances, non-price determinants of demand. So people come to market with certain income endowment, how much they're earning per month, per week is their income, and the higher the income, presumably the more they will spend on that given market. Yeah, so the income is an external circumstance for consumers coming to the market. It affects their demand, right? Secondly, again, the cross effects, the associations with other goods, with other markets for other goods. We have complements and substitutes. We will discuss some examples of complements and substitutes as we go. But yes, prices of other markets, prices rather prevailing in other markets for other goods, affect your own market, your own goods that you are analyzing is affected by prices for other goods. Then, of course, tastes and preferences, things go out of fashion, things enter into vogue, tastes and preferences of consumers. This is something external to the market, right? Consumers come to the market with their own preferences. And if those change, it's an external circumstance shifting, right? Not the internal circumstance of the market, but the external circumstance of consumers, their tastes and preferences. And other factors like the size of population in the country, government policies about especially the taxes, seasonal changes, the size of population say how it affects your markets. The bigger the population of a country, the more people are involved in a given market on the demand side, but also on the supply side as producers. So in terms of demand side of the market, the bigger the population, the more consumers are there on your market in question. The demand curve is higher. For the same price, there will be more people and they stand ready to buy more goods at the same price. As more people are there, right, at the same price, the demand curve shifts upwards. And so we have to analyze this idea about shifts and movements along in the curves. We have movements along the curve, and that's for internal factors. When you analyze them, like it's the internal ones, remember, the internal factors impact your analysis on the PQ plane. How? You don't change any associations for demand curves, supply curves, it's supply curve, it's demand curve. The associations are already indicated by them, right? If the market is stationary, nothing changes, the demand and supply curves are given to you as they are. What changes are, like you can move along the curve. For example, the price is declining right here. So in terms of demand, it means you're moving down the curve and along it. The price declines, the quantity consumed increases, right? Because it's an x-axis increasing here in that direction. So price declines, quantity increases. It's a law of demand, the inverse relation between the price and the quantity demanded. So when you analyze market in its own terms, so you can only analyze for movements, how to say, changes, okay, for prices and quantities demanded. P and Q's change and market being stationary, the price goes down, the quantity demanded increases. This is for you the movement along the curve. Nothing changes on the market, and the only way in which you move is up and down the curves. For demand, up and down, up and down. For supply, up or down, or depending on which point you select, from which you originate your movement, you can move outwards, further outside of equilibrium situation, or you can move towards the equilibrium situation. Remember, the point of stability is some equilibrium situation where the demand curve, that 1D curve, intersects the supply curve. And that's the only point stable. We discussed it in the past week. Other points have mechanisms moving situation which is out of order, out of equilibrium, back towards equilibrium. There's a mechanism for shortages here. There's a mechanism, the respective mechanism for surpluses when supply exceeds demand. You know, suppliers usually react that way. It's usually suppliers reacting that they, being initially found out of equilibrium, they move towards equilibrium. If they're found to be outside of the equilibrium point, they move towards equilibrium because it's beneficial for them. So demand side consumers from the demand side, right? They, in case they're found to be out of equilibrium, also have mechanisms to behave such as to result in the market settling down on that point, the point of equilibrium. There are mechanisms to move from out of equilibrium situations towards the equilibrium situations, but there are also disturbances causing shifts from equilibrium situations to outwards towards disequilibrium situations. But if you analyze the market in its own terms, those disturbances can only just go to be presented as movements along the curves. Just movements, the degree of freedom here, just you are free to move along the curves if you analyze the markets in terms of price and quantity changes. And that's when you analyze the markets on its own terms, on their own terms, right? Because the non-price determinants of demand are such that many other things come into play and change the external factors. The markets are outside the P and Q parameters that are internal. The rest of them are the external ones. They also affect the demand and supply analysis on the demand and supply P and Q plane. But now it's not the P and Q, the internal factors that are changing. It is the external factors that are changing, and how can they affect your analysis? The external factors, they are most likely to cause shifts in the demand and supply curves. All these factors operating on the demand side, they cause shifts in the demand curve. So your original demand curve is plotted here, right? And some external factors conspire to shift it either upwards and to the right. We can call it a shift to the right or a shift upwards. Whatever we call it, it's like it moves here, shifting upwards, or you can also call it a shift to the right, up to you. Or those factors can conspire to move the curve down. For example, let's analyze that situation, that case. Demand for carrots if there's an increase in the size of population. So we're analyzing what? We're analyzing carrots market, some market for carrots. Just let me draw the initial situation. The original situation is assumed to be there for that very market for carrots. In that situation, and you will have many such instances during your exam, you'll be given some market for carrots, for example, and something changes for that market. Here we have the increase in the size of population, and then you have to analyze what happens to the market subsequent to the change. The change, first you have to answer the question, is whether it's an external one or the internal one. The internal changes are changes in the market on its own terms. These are the changes in P's and Q's only. Any external factors are, by implication, external circumstances, most likely to cause shifts in the curves themselves. So the original curves, this is, let's say, RP, this is RQ axis, this is the downward sloping curve for demand, this is the one for supply, and the original equilibrium situation is given here, Q of 0, that's the original equilibrium situation. The stable situation, we suppose that is the original situation on which the market is settled. It's a stable one, the original equilibrium situation. Equilibrium at t of 0, at time of 0, the initial one. So it's denoted with E0, right? The initial equilibrium E0. And that point has a certain associated Q value in terms of quantity sold on the market at that equilibrium price P0, right? P equilibrium 0. So there's a shift now happening, the external one happening to that market. It's a change using something. What happens is that the increase in population is there. So as the country becomes bigger, right, in terms of its population, more consumers will be likely to buy carrots. They enter that market for carrots and consume in aggregate. Now they will consume more carrots for every same price. For every price out there, instead of consuming that much of carrots or that much of carrots for every single price on the price axis, they will end up consuming more carrots now For that price, they will also consume not here, but that much of carrots, that many carrots. And for that price, instead of consuming that many carrots, they will tend to consume more carrots. So any price you can think about, instead of the original consumption for carrots, the consumers in aggregate, all of them, they are now bigger in size, so all of them will start demanding more carrots for any given price. Okay, so it looks as if our curve being originally positioned here, now it shifts to the right. So upwards and to the right, so to speak, upwards and to the right. There's a shift in the curve from D of 0, the original demand curve, to D of 1, which is your new demand curve. And so next, instead of the original equilibrium point, you are having some new equilibrium point, and you have to analyze its properties. Just to repeat that idea, to give the step-by-step process for such an analysis, let's do it in Word, because here I already developed some planes. Step number 1 for such an analysis that you will do at your exam is to, step number 1, okay, is to just plot an original initial equilibrium situation for the market in question. So we have just one market for carrots, right? Plot the original equilibrium situation, the demand curve being the downward sloping one, the supply curve being increasing. Mention which axes are there. The axis we are using, say for y, on y-axis you put the p value, the price changes, and on the x-axis you put the quantity changes. Mention whether this axis is p or q or the other way. Remember, there's a direct presentation and there's an inverse one. We are using the inverse presentation, same as in your Sloman textbook. So p is the y-axis, q is your x-axis. Mention the equilibrium point, call it E0. E0, the initial one. This is mentioned that this is your supply curve, this is your demand curve, right? And step number 1, draw the original situation. So your original situation is at equilibrium at quantity sold Q0 and price at equilibrium is P0, right? Step number 1, do that. Draft this PQ plane with the curves populating it, and draw the original equilibrium point for Q and P. Step number 2, analyze what is happening to that market for in question, the market for carrots. That's step number 2. Is it the internal circumstance that is changing the market, or some external one? Is it external or internal? Let's see in the slides. Increasing population. Remember, the only internal ones are the price changing and quantity changing on the market. When this P and Q parameters change, this is the market analyzed in its own terms, not on its own merits, in terms of its own independent or independent variables, the P and the Qs. The other changes are the external factors, including the income, including the change in population. So the external circumstances is changing for our market. There's increase in the size of population, more population, along like same as for any other external circumstance, will do what? It will shift, or in most of the instances, it will shift your demand curve, and we are interested here just in demand curves, right? In demand curves. So what happens to your demand curve for that market? It can shift up or down, but if there is more population, now you have to think, what happens if there's more population? For every same price, since there's more people entering the market, there will be more demand. For every price schedule, for every price point on that axis here, instead of the original demand, there will be high demand. For that point also, instead of the original demand here, you will have high demand. So the idea is that your new curve will join up all those points which are placed rightwards from the original points, rightwards. For this point, for example, it will be rightwards. The new curve runs parallel, joining all those new points with high demand associated for the same price. The new curve for demand shifts to the right or upwards, but it shifts like that, right, compared to the original one. The original one was that one, and the new one is, so let's call the original one now D0, right, the original D0, and the new one D1. And so the point of stability the point of new stability on which the market will be expected to settle will be that new equilibrium point, right? E1 compared to the original one. That point of equilibrium will have higher price. So this is the point, right? P1 compared to the original point which had the P0 coordinate for P, the new one, the new point of equilibrium will have the higher price. And in terms of quantity, the new point, the original one was placed here, the new one will be placed here on that axis. It will be Q1, right? So it will have a high Q compared to the old point and high price. So the new equilibrium, E1, we are calling that equilibrium, right? E1 has its properties of having the high price and the high equilibrium quantity sold at that price. So that's our statement. We discovered that in consequence of something external happening to the market, right? The increase in the price of population, the demand curve shifts upwards. It moves from here to there, shifts upwards or to the right. There's a new demand curve, so there's a new equilibrium point, and that new equilibrium point, E1, that one, compared to the old one, that new one has its properties of higher equilibrium price and higher quantity sold at that equilibrium price. The equilibrium quantity will also be higher. If the demand curve shifts upwards in connection with some external circumstances related to your original market for carrots, right? The new property of equilibrium will be like that. The new equilibrium will have high price, both high price and a high quantity sold at that price. And that's the last step of your analysis. So step number 2 is to decide whether it's external or internal parameter affecting the market. Step number 3 is to analyze whether it's a shift in the curve or a movement along the curve and in which direction, and in which direction is a shift. Here it's a shift to the rightward and upwards, so it's an increased demand, shifting your curve for demand to the right. And in association with that, the last step, step number 4, that's a fourth step, right, is to analyze the properties of new equilibrium originating at that new equilibrium point, and the new equilibrium will have the high price, P1 will be higher, and Q1 will be also high compared to the original P0 and Q0 quantities. The demand measured in number of items sold per, maybe not per second, but let's say per on the gold market from the past week, we had this per second, I think, development, but here let's say it's a market for carrots, so it's per day. Quantity sold per day, and the price at which that quantity is sold, the uniform price for the quantity which is uniformly sold at that single price, the law of one price. Remember the law of one price, the law of single price. All this quantity is sold at a single price. Even though the cars associate different prices with different quantities, there's one stable situation at which the entire quantity brought to the market is sold, right? And that is a stable situation, the equilibrium point. We're analyzing the properties of that equilibrium point. So this is how you approach this assignments. And let's do some other assignments, like more complex one, because here that sort of stuff, deciding whether it's a movement along the curve or a shift in the curve. It can be demand curve, supply curve. Here we are mostly concerned with demand, but not quite. Let's analyze some more complex situation. Maybe that one for electric cars, when the demand for oil is rising. So we have a market for electric cars. We have the market for oil. Also, in the background, we have a market for normal cars, like the petrol cars, right? So we have also petrol cars in the background, petrol cars. And we shouldn't neglect those. So actually, there's 3 markets involved in the question. Something happens on the market for oil, where the prices are rising. This will affect the market for petrol cars, and also the market for electric cars. Now, there is an association between these goods, electric cars and petrol cars. How is this association called? It's called the association between substitute goods. Substitutes. The electric cars and the petrol cars are substitutes. They perform same functions to transport you for longer distances. So you can opt for any because the functionality is pretty much similar. But the electric ones run on battery, but the petrol ones run on petrol produced from oil. So something is going to shift here for petrol cars because the oil is rising, and that has repercussions for the cost of petrol at the petrol pump, right, when you fill up your cars. And so this is going to affect somehow the demand for petrol cars, right? This demand for that market and the demand for the market for electric cars, they are somehow associated because there is some association between the demand for substitute goods. Your petrol cars and your electric cars are substitute goods. Another example of a substitute good would be, say, an iPhone. You can buy an iPhone, or you can buy a normal Samsung or Android phone, right? iPhone compared to Samsung, right? Samsung. So substitutes, yes, almost perfect substitutes. You can use either the same functionality, pretty much very close substitutes. If the price for Samsung is less, maybe you'll tend to buy more of Samsung devices. But if the price for Samsung increases, actually you get very expensive Samsung devices presently. There are some models, so maybe you better buy an iPhone. So it much depends on the relationship between the prices for iPhones and Samsungs. A price for Samsung goes up, and then something will happen on the market for iPhones, because maybe you will switch your preferences from Samsung to iPhones. And if iPhones are getting increasingly expensive, maybe you'll switch your preference from iPhone to Samsung device. So there's cross association, like again, we are using that word cross association between the market for substitute goods. Cross, cross, cross effects, right? Cross effects. Let's explore these effects, but not for iPhones and Samsungs. Let's carry on with that example for electric cars and petrol cars. Again, I'm switching to my Vortex example, and here we have two markets because we have substitutes, right? The petrol vehicles, the petrol cars. That's your first item to analyze. The first market to analyze: petrol cars and electric cars. One market affects the other, as I told you, electric. So in the background, there's a market for oil, and we know that the price for oil goes up. This has repercussions on for the cost of fueling cars. So for the cost of fueling up petrol cars at the petrol stations, if the price for oil goes up consistently and is lasting at a very high level for very long, will you be consuming more petrol cars or less whenever you decide to change a car to sell the old one and buy a new one? Will you be consuming more petrol cars or less if the price for oil keeps increasing and now it's costing you to run a petrol car because the oil is highly priced? I guess because the oil is consistently highly priced, the original demand for the petrol cars will decrease, right? The original equilibrium with this existing supply curve was like that. Now, with the oil being very expensive, people will tend to consume less of petrol cars at every price. At that price, they were consuming that much originally, but they will tend to consume less. At every such price, at that price, instead of consuming that much, they will tend to consume less, again less, at that price P, right? Instead of consuming that much, here they will tend to consume less. So that looks like a shift in the demand curve downwards. Again, in relation to petrol cars, the price for oil is an external circumstance. We're analyzing some shift in the market associated with petrol cars, but it's an external market. What's happening on the market for oil is an external circumstance. So again, we see that an external circumstance in association with some market causes a shift. It's a shift in the demand curve. In that instance, it's a shift not upwards, not that, but it's a shift downwards or to the left, whatever you call it. It's a shift downwards or to the left. So the new equilibrium point is actually established with respect to the same supply curve. We assume that supply curve doesn't shift. Only the demand curve is shifting in that exercise. So the new equilibrium point will be established here E1 is a new one, and it will have these properties for the petrol cars, right? That the new quantity, new equilibrium quantity Q1 will be less than the original quantity. It will be less. So the new equilibrium point for petrol cars has this property. Let's say quantity is less, but the principal thing is also the price. As we shift from that point, the old equilibrium to the new equilibrium point, the price reduces from that price down all the way down to that price P1. It reduces. So the price reduces, as we just mentioned, and we also notice that the quantity sold at the new equilibrium price goes back from that quantity down to the new quantity here. So it goes down. The price goes down at the new equilibrium point, and also the quantity of goods sold at this price declines. P is down and Q is down. Okay. External circumstances, the price of oil cues the demand curve to shift downwards. The new equilibrium situation is less petrol cars are going to be consumed at lesser price. Okay, less petrol cars are going to be consumed at a less equilibrium price, and that's because the demand declined, and part of demand that disappeared from that market in consequence of the shift of demand curve downwards. Part of the demand that disappeared from the market for petrol cars actually reappeared on the market for electric cars, because when it costs too much to operate petrol cars, you shift your preferences from petrol cars to a substitute good called the electric car. You decide to buy more. Generally, everyone decides to do that thing, to shift their preference from petrol cars to electric cars. You switch from petrol to electric. And in connection with that switch, right, for every price on the electric car market, now we're analyzing the electric car market. For every price on that market, the new demand will be high. For every original price point that you can think of, conceivably, right? That one, the new demand situation will have you have more demand at the same price, right? You have more demand at the same price. For every price point now, the old demand was like that, and the new demand will be higher. Does it look like your demand curve is shifting to the right? Yes, it looks to be the case. Again, your demand curve for the electric car shifts to the right or upwards, whatever you call it. Basically, it's to the right and upwards, both of, right? You can also depict the change with these arrows like that. So it's to the right and upwards. The original demand station was the demand curve was D0. The new one is called D1. And the original equilibrium was E0, right? And the new equilibrium will be called E1. What is the property of that new equilibrium for the market, on the electric cars market? Let's see. In terms of price, let's discuss. First, we analyze the property of new equilibrium, usually with respect to price. So the old price was here, P0, and the new one, that equilibrium price, is actually higher than the original one. So your equilibrium price increases. P equilibrium increases, right? And your equilibrium quantity associated with that new equilibrium price, the price increases, but the quantity went from that quantity Q0 all the way to that new quantity Q1, right? So the quantity also had increased. So we answered that question. What happens to the demand curve for electric cars, assuming the price of oil is perennially high now? It's increasing constantly, continuously. And what happens? We have a multi-stage process. First, because the oil price is increasing, the owners of petrol cars notice that it costs them dear to operate and maintain petrol cars. So the demand for old petrol cars for the petrol technology declines, using the new equilibrium point on the petrol car market. And the new equilibrium point has a lesser price, and at that lesser price, lesser quantity of cars are sold, the petrol cars, right? And this has repercussions for your substitute goods. For the petrol car, the substitute good is electric car, because that car is now, as demand shifts down, right? It's getting too expensive to operate. The price of the car itself reduces, but it's getting simply too expensive to operate. The capital cost, so to speak, is low, but the regular maintenance cost is very high because you need to spend on petrol. So people don't like that. They buy less cars for running on petrol and switch to electric cars. On the substitute market, now we analyze what is happening on the substitute market. Our destination of, so to speak, like our final point of analysis is what is happening on the electric car market. And so something external to that market happened, something external on the oil market happened, something external happened on the market for substitutes, for the electric cars, the petrol cars as a substitutes. And those externalities, those external factors caused the demand curve to shift upwards on the market for electric cars. And now that was a step 3 of analysis. We know that the demand curve shifts upwards or to the right, upwards and to the right. The equilibrium point has been established at this area of the PQ plane, and it has its properties compared to the old one. That is old, that is new. The new one will have the high equilibrium price, and at this price, more cars will be sold. But still, you don't have to spend on petrol, right? So yeah, you buy more cars, even at the high price, because you save up on petrol, which is now very, very expensive. So nothing unusual. You just analyze the market in terms of shifts here, right? Because what is happening as a shifts here, it's specifically in demand curve, because we are asked to analyze demand curves, right? Demand curves for cars. That's what we are asked to analyze. The demand for electric cars. This is an example, right? We asked to analyze the demand curves. So we analyze the shift, and as a shift in consequence of some external circumstances shifting, right? Changing. That's the external circumstance that cause the curves to shift. Usually with something external, then the curves are shifting. If it's something external like the P and the Q, then the curves are not shifting, they stay stationary, they stay the same, but you have movements along the curves. And let's consider some such example where you have movements along the curves. This is the example, right? Demand for ice cream when the price for ice cream went up. We are done with petrol cars. Now, for change, let's illustrate the situation. We are asked to imagine what's happening to the demand curve for the ice cream when the price for the ice cream went up. The market is that for an ice cream. What is changing on that market? Is it something external or internal to the market that is changing? The price on that market is changing. The price parameter, well, it's that parameter that we have mentioned on the y-axis. So it's internal parameter of the market. When it's something internal to the market that is shifting, it's not the shift that we are discussing. It's a movement up and down the existing curves. So when the market is stationary, and it's only the terms of the market that are changing, the internal ones, right? The internal parameters. You are moving along the curves. Your movement on the PQ plane is very limited. You just go up and down the curve, and in that instance, we ask to imagine what's happening in our movements up and down the demand curve. And we are not told from where to start in that exercise. We are really not told from where we are starting. So let's just again do step number 1: draw up a plane for the PQ plane for the market for ice cream. Let's have it here, ice cream, right? Our initial position, well, it can be anywhere on the demand curve because we're analyzing the demand curve. We are told to analyze the demand curve. Let's say we are here, out of equilibrium. You can also imagine yourself being in that exercise at the point of equilibrium, but let's say we are to the right of the equilibrium point, we are here. And now this is our original initial position, and the price, we are told, increases, right? The price on the market for ice cream increases in consequence of that, and nothing changes. We are analyzing the market on its own terms. No external factors are changing. Only the P term of the market, that price instrument affecting demand and supply changes. The price increases. So we are moving as the price increases, meaning from that original price to some new price, it increases. and we move along the curve to some, presumably towards equilibrium, because the stable situation on the market is the equilibrium point. So we move from out of equilibrium situation towards the equilibrium situation. It's a movement along the curve, the demand curve, because we are told nothing changes on the market except that the price adjusts. That's internal factor, internal, right? Internal. PQs are the internal ones, so it's never a shift. It's just a movement along. If the internal factor changes, it's not the shift of the curve, it's a movement along the curve. So let's say we are moving from that position to the equilibrium position. Price increases, right? Because we are told it's supposed to increase, that's what is given. We are moving in the direction where the price increases. And what happens to quantity as this price increases and we move along the line, the quantity reduces. The quantity sold at the new price will always reduce as the price declines, as the price increases. Quantity reduces, right? Quantity reduces. In other words, we were asked to restate the law of demand, right? The law of demand is such that as you have lesser prices, the market will operate on its own terms such that the lesser prices associated with high quantities of goods demanded. At the lesser prices, more will be demanded, right? But in our instance, it's a high price that is being researched. So at a high price, the quantity demanded will be less at every high price. Of course, I'm just imagining that our original point of departure was out of equilibrium here, right? And the price went up and nothing changes outside of the market, so we move along the curve for demand. I just imagine that a starting point, we could have just as well drawn our starting point at equilibrium, and maybe we are told that due to some disturbances, maybe something, right, we moved outwards from the equilibrium station to non-equilibrium station, and on the demand curve, because it's the internal parameter, so nothing changes. Only the internal parameter is affected. It's also movement along, but now it's a situation of moving outwards from the equilibrium point towards non-equilibrium point. It's hard to imagine that it can happen without any external disturbance. That's why I think the first situation that initially by some misfortune we are found to be out of equilibrium and the market adjusts as you move, right? It's a surplus situation here. Remember in the past week we discussed the mechanism for this movement along the curve. If at this point of analysis we as buyers are here and in consequence our suppliers are found to be here, there's a mismatch between demand and supply. Is it actually a surplus situation? Because in the past week I use that as an inversion for P and Q axes. So I guess at that price, the demand outstrips supply, right? This is S and this is D. Demand is higher than supply. So actually our original situation was to have demand being higher than supply, and this is characteristic of a shortage, right? So this is shortage situation. We are at a shortage, the market deficit point, demand outstrips supply at this price. At this price, our demand is higher than supply. Remember, there was a mechanism that the sellers enact in that instance to maximize their revenue, because they noticed that in their warehouse, the stockpile of whatever they are selling, carrots, right? Or was it an ice cream? In that example, it was an ice cream, right? An ice cream. So in that station, what we'll have is that we have a shortage developing. The stockpile of ice cream in the warehouses is less. So they can easily increase the price. The revenue is what? It's a product of price, P times Q, right? They can increase the price and still they realize that they can sell more even at a higher price because the demand outstrips supplies, right? So even at some high price here, they can still sell more. Sell more. That's what they were selling here. Now at a high price, the price increases, they can still sell more because the demand is so high. They were selling for some miscalculation on their part, maybe lack of production capacity, whatever. They were selling very little, and they can still increase the price and sell more. The price increases, they sell more. and they maximize or just attempt to increase the revenue as they move along the supply curve towards the equilibrium, right? They react to that deficit, to the shortage on the market. The suppliers do. They move along the supply curve by increasing the price and increasing the quantity sold. That's their adjustment mechanism. That's why we say that there's always mechanism to achieve that out of equilibrium situations are rectified on their own terms by the market mechanism. The price adjusts from outlying out of equilibrium points towards the point of equilibrium. The market adjusts on its own terms. We have been just discussing the internal parameter, right? The internal parameter along the demand curve, because we were told to analyze a shift along the demand curve from some out of equilibrium point. But we can also analyze a shift in the supply curve from some out of equilibrium point towards the equilibrium point. We did it in the past week when we discussed what happens when the market is out of equilibrium. Again, we're just refreshing. The movement along the curves happens when the market is equilibrium, and that's when it's out of equilibrium on its own terms by miscalculation on the part of the parties involved, the buyers and the sellers. We can continue with some examples. Maybe we did an example for electric cars and petrol cars. Those were the substitutes, right? The substitutes. We did already an example for substitutes. Let's do an example for complements. If your Samsung device and iPhone device, if your electric car and your petrol car as substitutes, also obviously we can imagine a situation for complements, right? The reverse situation. So you have substitutes, right? But you also have, by implication, complements. What are the complementary goods? Complements. So your iPhone, when you buy an iPhone, you also buy a protective glass for it and the cover. So for an iPhone or just any other phone, its cover and its protective screen, right? The protective glass will be the complements, right? If you consume more of one item, you will also consume more of the other. If you consume more iPhones, for some reason, you will consume more of protective glasses and more of the covers. And here we ask to imagine the situation, but not with iPhones and the covers and the glasses, but with cornflakes and milk. With cornflakes and milk. Are they indeed complements or substitutes? They are not substitutes because, well, the functionality, the taste is different for milk and cornflakes, and well, one is liquid, another is solid and crunchy. One is non-crunchy, you just drink it, you can gulp the milk. But cornflakes, if you just eat it solid without moistening it first, you will just scratch your throat. So I guess certainly not substitutes, their function is different, but they're excellent complements, because to make sure the cornflakes are moistened, you eat them with milk, right? You put some milk on top of cornflakes and they're moist enough not to scratch your throat. So these are two associated in relation of complements. They're complementary goods. As the demand for one thing increases, you eat more cornflakes for some reason, you will also consume more milk, precisely because cornflakes, they go well with the milk. You always, if you eat a cornflakes, you put some milk in them, so the demand for one item changes, and the demand for another one will also follow suit. It will change simultaneously in association with the demand for the former. The demand for the latter will change in association with the demand for the former. Again, two markets, but now our goods are the complements. And we are told that the cornflakes becomes cheaper. We don't know why it becomes cheaper, but let's imagine some situations, some conceivable stations. Again, we have two markets, one for cornflakes, and something actually develops, changes on the market for cornflakes. Cornflakes becomes cheaper. What does it mean? What can cause cornflakes to be cheaper? Well, maybe, let's say, supply was affected such that at every price, a new productive capacity for cornflakes was commissioned. So there was a new producer entered the market producing cornflakes. So for every same price, that situation for supply on the market changes. There's a new producer, and because of that, the supply curve, that's the supply curve, right, changes. such that with a new producer at every same price, more will be supplied. At that price, not that, but more will be supplied. At that price, not that, but more will be supplied. Even at that price, not that, not that, but more will be supplied. So all these points, they indicate a shift in the supply curve, a shift from S0 and the former equilibrium to some new equilibrium in connection with a shift in the supply curve. The new equilibrium is established where the new supply curve S1 intersects the original demand curve, that point, right? And compared to the original equilibrium, that point will have, compared to the original equilibrium in terms of price, that new point will have for cornflakes, right? The new point will have less price. We go down in price from here to there. It's a reduction in price. P reduces, but your Q, as you go down from that point to that point, I guess your Q moves from that value to that value. It increases, right? That's a statement about pretty much. We are told what happens. We are told that the price for cornflakes reduces, cornflakes becomes cheaper, and we are assuming it's an equilibrium price. So now the new state of the cornflakes market is such that indeed the price is reduced, but the quantity consumed of cornflakes is higher in consequence of the shift in the supply curve for cornflakes from the old one, that one, to the new one, that one. The cornflakes price is reduced, and you will consume more of cornflakes. You will consume more of cornflakes, and cornflakes is consumed with the milk, right? So you will end up not just consuming more cornflakes, but also consuming more milk, and that's a market for milk. Now we are analyzing the subject market, the market for milk, the market for which we are asked to conduct the analysis. So now, because milk is consumed with cornflakes and there's more demand for cornflakes, what will happen to the demand for milk at every same price? Because you need to consume more cornflakes, and in fact it's consumed in greater quantities. So for milk, at every price there will be more demand. Instead of that demand at that price, will be some higher demand. Instead of that demand at that price, there will be some higher demand. Instead of that demand at that price, there will be some high demand. So what happens, it's like the demand curve is shifting in that direction, right and upwards, right? Pretty much that's a shift in demand curve upwards. Let's call it the shift upwards. The new demand curve, instead of the original one, D0, is a D1. The new equilibrium point instead of E0 is that new equilibrium point E1, right? That one where the curves intersect, it's E1. And let's analyze the properties of that new equilibrium point compared to the old one. The old one had that price P0, and the new one has some high price P1, right? So some high price meaning the price increases, P increases, and Q, so price increases, but Q, the original Q was here, and the new Q is here. So Q, the original Q is that one, and the new one is that one, right? The Q increases. At the new equilibrium point, that one, the Q is also higher. So it's a statement of change in the demand curve. It shifts. It's the external circumstance. Something happened for the market for cornflakes in relation to the market for milk. What happens on the market for cornflakes is an external circumstance. Again, the external circumstance, the tentacle shifts in the subject market of analysis. And we have a shift in demand curve because that's what we are told to analyze, the demand curve. We assume supply curve is still constant. Okay, so we have a shift in the demand curve upwards, and at new equilibrium point, the market settles to some operational state, and that operational state is such that compared to the old state, the price is high and the quantity consumed at that price is also higher. That's a statement on the situation that we are asked to analyze. We have two complementary goods, the cornflakes and the milk. and being complements, right? That first thing, the conflicts becomes cheaper, you consume more of it, and also you consume more of milk, and so in consequence of that, the price for milk is increased, and the quantity of milk consumed is increased. But the price for conflicts became cheaper. Okay, so it's a statement, the result of our analysis. That's what we are finding for the happenings in respect to associated markets, the milk and the conflicts. Of course, you can continue your analysis like that down the line. So here for the conflicts, we had a shift in the demand curve for milk. Like I actually canceled the doodle, but we have a shift. And so we had high price and high quantity for milk, right? For milk. But maybe subsequent to the shift in the demand curve to the new one, maybe supply curve will react, right? Somehow. So the equilibrium will shift from that point to that point, then supply curve. Some new producers of milk will enter the market, and the supply curve will shift because they will enter the market because they see the price increasing. So let's say they enter the market, the suppliers of milk, they do. And so the new supply curve will shift like to that, from that old one, S0 to S0 to S1, right, S1. So I have the new equilibrium point establishing itself with the supply curve shifting subsequently to the increase in the price for milk. The original point was that one, the second one was that one that we had just analyzed, we finished analyzing, and now there's a third equilibrium point, and so there's evolution of equilibrium points from here to there, let's say. So the markets are found in a constant jostling. The demand and supply curves are constantly jostle in adaptation to each other. Adapt and jostle, they change the locus of intersection points. The equilibrium point always moves and migrates in this time. And depending on the time frame of analysis, well, you have this idea that the things are fluid, the things evolve, and the equilibrium points also evolve. Equilibrium point is not, it's always the same point. It's a stable point, but even that stable point evolves. It's stable, but not stable, right? Stability itself is a fluid category on a market as a living organism. It's fluid. It shifts and migrates. So I have this very vibrant vision about how markets function and how the demand and supply curves can support these movements of markets on their own terms on the PQ plane, right? How markets react to changes on their own terms, movements along the curves, right? How they react to external circumstances using shifts in the curves. So I have movements and shifts. Remember, in the exam, you will be asked to distinguish. You will be given some such examples, right? You will be told to analyze some curve. It can be supply curve or a demand curve. Today we are actually focusing on demand curves, but we also mentioned some supply curves shifting. So I will be asked to analyze some demand curve on some market in connection with a change maybe on that market, the internal change using the movement, or the external change using a shift in the curve, the demand curve, right? So I have to decide which situation is it. Is it a movement situation when something changes like the price of ice cream? Or it can be usually a shift situation when, for the other examples, we had shifts used by external circumstances external to the market. Your exam paper will be largely focused on these matters. Please do remember that it's important to differentiate between movements and shifts on the PQ plane for the curves depicted. We'll continue with the examples like that during the tutorial in the next week. This week we'll do an exercise to develop the demand curve for your class for Plov and SOMSA. But the next week we'll do some similar exercises. So we'll build up that skill for you about analyzing shifts and movements on the PQ plane. So this is a very vibrant vision about the curves shifting, intersecting, and there are problems. Like actually, when you analyze markets, what happens is that you have to answer questions about whether an equilibrium point exists. If it exists, is it just a single point, or like that here we have a demand curve crossing supply curve in 2 points. It's a singular equilibrium, or maybe there's several equilibrium point. Is particular point out there a stable equilibrium point or non-stable one? Is there some mechanism if you depart from that point? Is there some mechanism on the market to bring your market back to function at that point, or there is no such mechanism? If there's no such mechanism to alleviate or just obviate departures from the equilibrium point, then the equilibrium is non-stable. It's just a point, but there's little economic significance to that point. The point of equilibrium is itself non-stable. So you rule out some multiple equilibrium. Maybe you settle just on one equilibrium point which is stable. So you can then analyze and present market functioning as being stable at the point of stable equilibrium, right? That's where the market converges to those points of stable equilibrium. But there are other points which are not stable. Yeah, mathematical economists, they're involved in that sort of analysis, analyzing stability, singularity of equilibrium points. And this is a very vibrant vision. That person who popularized the idea of demand curves, right, and introduced inverted presentation with P on the y-axis. Marshall, right, he actually mentioned that markets analyzed in connection with the 3 periods of their operations. In short term, the supply curve doesn't shift. The supply in a very short term, like 1 day, remember the case of the fish market, right? For 1 day, the supply is fixed. In the case of the fish market, the demand shifts, but supply is fixed. The sellers bring all their wares to the market. On that day, the supply is fixed. So in short term, Marshall said that, yeah, there are periods of markets operations. In the short-term period, the supply curve cannot shift. By definition, a short-term period of market operation is when the supply curve doesn't have time to adjust, doesn't shift. But the demand curve can still shift. Over the short period, like the next period, like midpoint, like middle period, you can have some shifts in the supply curve, but your productive capacity is limited, so those shifts are limited. Over long term, the supply curve can adjust in a variety of ways to the changes in demand, so it's very flexible. Then in over long term, the longer the time frame allowed for analysis, the more flexible is your supply curve. Right, so in terms of market functioning, Marshall introduced that idea of different flexibility to the supply curve when it doesn't change, cannot change, doesn't have time to change. That's your temporary period of market operation, or you can also call it a very short-term period of market operation. If there's time allowed for the supply to change, then we are discussing a period of market operation. It's a longer term or a very long term period of market operation. That's 3 periods: very short term, and long term, right? Pretty much like that. This is with respect to distinction by how much your supply curve can change. This is the distinction with respect to the shifts and movements in the supply curve, the periods of market operation. For example, there's another case I think illustrated here. Very much similar to those cases we discussed with on that slide, right? The cases for milk and cornflakes, we ended that case. But that case, I think, is a good one because it helps you also to associate markets with certain periods or horizons of market operation. Market for coffee, right? And the last case is it calls on you to answer what will happen to supply and demand to that PQ plane, pretty much in which with which you illustrate the coffee market. What happens if there's a severe drought that kills half of the harvest of coffee beans? So again, there's some drought killing half of the harvest of coffee beans. What happens to the market? Again, there's a regional station on that market for coffee beans. It's a coffee beans market. Coffee beans. And that's your original station. Q0, P0, the equilibrium station. Now something happens, drought happens. Is it something happening? Does it happen to the demand curve or the supply curve? Drought, it kills the beans grown by producers, the suppliers. So obviously the supply side of the market is affected. There's a drought, right? So now that there's less of supply for every price, how will this curve shift? Because a drought, think, is an external circumstance to the market. The precipitation of rain was less, right? So there's a drought developing, affecting your supply curve because it's producers who are suffering in consequence of the drought. How they are suffering? Now they will stand ready, I guess, to supply less at every same price. They will stand ready to supply less. At that price, instead of supplying Z, they will supply less. At that price, instead of supplying Z, they will supply less. Your pretty much supply curve shifts from S0, that original one here, to that new supply curve S1, right? And your new equilibrium point in consequence will have which properties? The new one, E0, E1. Compared to the old point, the price will go up. So your new point E1 will have these properties, price increasing, price with arrow pointed upwards, price increasing, and your new equilibrium will have lesser quantity of goods supplied at the new equilibrium point. So quantity from here to there is decreasing. P is high, Q exchange at that equilibrium P is less. But I'm not just repeating about the shifts, but this time it's a shift in supply curve, right? Actually, I'm not just repeating about the shifts of the curves caused by external circumstances. What I'm trying to introduce to you is the idea that when a supply curve shifts, by implication or by definition, we are already discussing longer term, not a short term period of market operation, but a longer term period of market operation. By definition, when we are allowing more time for the supply curve to shift, right? We are already discussing a market operating over a longer term, not on the time frames of one day, but on a longer term time frame, because the supply curve shifts. Well, it takes maybe not weeks but months to develop the drought, right? So it's not that year's harvest that's going to suffer, it's the next year's harvest that's going to suffer from drought. So we are discussing with the time frame in which drought develops, we're discussing a longer term period of market operation. Okay, so this is the idea that Marshall introduced to use that the different periods of market operation, and depending on the time frame of your analysis, you can have only just demand curve shifting, but then as the time frame of your analysis increases, then what's happening is you can allow for shifts in supply curves, and because it's a shift in the supply curve, the drought situation by implication analyzes the market over a longer term, not a short term. On the short term, nothing happens to supply. So, well, we introduce the idea of market horizons, time frames for market operation. When the supply curve is shifting on the market by application, we are discussing periods which are longer term periods. Over short term, nothing can happen to supply curves. By the definition, the time frame of analysis is very less to allow for the change in the supply curves. Next, we can do what? We can discuss. Well, let's do some exercise rather, right? We can do some exercise just to depict an equilibrium point. Market equilibrium, we will do that in GeoBra. So we ask just to draw this demand curve and this supply curve. Again, the demand curve is downward sloping as it should be, so the slope is negative, indicating the downward sloping curve, right? And the intercept is positive, indicating that the curve will intersect very high above the x-axis. The y-axis intersection will be very high above the x-axis. And the supply curve, having the positive intercept, is the upward sloping one, so it's okay. The normal good is being analyzed. Let's do that exercise in GeoBra. So we have to develop this function and this function. 9 minus 100 times p. Let's start the calculator. Demand is a function of price. And what is the function? It's 9 times p. 900 minus times p. Don't be deluded. We don't have anything wrong with GeoBra. We have the scale situation. The slope is very steep, right? And so your curve, being the declining one, it looks like almost like a vertical line running in parallel to y-axis, but it doesn't quite run parallel because you can see if you just increase the scale or rather decrease, reduce the scale, there you'll have the intercept point exactly the 900 point. Your intercept, right, is here. So that's a scale situation. The price was a good, it's a mass-produced good, right? The price is very small one, a low one, but the good is produced in huge quantities. It's a mass market, so at this tiny price, lots of goods are churned out at factories. So that's a market for some very small good produced in mass quantities, right? In mass quantities with that intercept and a very steep slope. The supply curve, I think, has also very similar properties. It's 200 times P, right? Yeah. The blue one is a supply curve, and it should be upward sloping, but again, it's almost like vertical because it's too much upward sloping. The slope is very high, and there is no intercept because the curve runs through origin. That supply curve indeed starts its origin and then moves very steeply upwards. Will it intersect the demand curve? Yes, because the demand curve, even though almost vertical, it's leaning to the left. It's leaning. You can see it's leaning, a little bit leaning to the left, and that one is still, even though almost looking like vertical, it's still leaning to the right. The blue line leans to the right. So eventually they will intersect. Again, just change the scale and go down. Just scroll down, right? Scroll. Here you have this point of intersection at 600. Jobra took care to depict where the lines, not curves, these are straight lines. Okay, there is a straight lines intersect. And if you now increase the scale, you notice that the price, the equilibrium price, we cannot really tell that equilibrium price, but we can see that it's very close to zero. And at the equilibrium price, the quantity sold on that market will be 600. That's where the cars intersect, right? 600 sold at some low price. We cannot quite use GeoBra to find that low price associated with that point of equilibrium, the 600 in terms of quantity. But if we do the algebra, the bit of algebra like with numerically, we can estimate that price. How? Well, at the equilibrium point, you know that the quantity of goods demanded and the quantity of goods supplied is much at the same. So the quantity of goods demanded and the quantity of goods supplied, these two quantities should be made equal. I'm already getting better with this thing, with the epic pen. So we should equate the demand curve presentation formula to the supply curve presentation formula. Let's do that. So 900 minus 100p equals 200p. Let's move 200p. Let's move p to one side and leave numbers on the left. So then we have with minus, it moves to that side with plus sign, the sign inverse. So we have 200p plus 100p, 300p on one side, and the only thing remaining on that side is 900. So your p at the equilibrium point will be 900 divided by 300, which is 3, right? 900 divided by 300 is 3. That will be your equilibrium price. That ensures that the quantity demanded and supplied are equal to each other, and therefore this is your equilibrium quantity supplied at that equilibrium price. The equilibrium price we just found is $3 per unit, and the equilibrium quantity, we already did that analysis in GeoBra, so we know it's 600, but you can also estimate it by substituting that equilibrium price of $3 to any, or just rather to either of these equations. Let's substitute to that simpler one. 200 times 3 is 600. So we know in terms of quantity, the equilibrium point will have that quantity, and in terms of price, we just found it to be $3. And GeoBra proves our intuition, right? GeoBra proves our intuition. It says that the equilibrium quantity is some high number, that 600 amount, that 600 amount, 600. But because we have that scale, the funny scale, right? So we cannot quite tell the equilibrium price, but just by looking at what happens on the GeoBra plane. One more thing we can discuss is that controversy about V-value, that stable equilibrium price is called value. Or there was a controversy before Marshall, that person introducing to use the idea of horizons of market functioning, right? The time frames of market functioning, the short-term horizon when supply doesn't have time to adjust, the longer-term horizon of market functioning when supply has some flexibility and the supply curve shifts. This very same person also had this to say about the accusation. What determines the equilibrium price on the market? Is it demand that determines it? Is it the supply that determines it? Because before Marshall there was a controversy, right? There was a very huge controversy because the classical economists claimed that Adam Smith claims that the price is determined by costs. He had a cost theory of value. Then there were some marginalists like that Jevons person who developed the marginalist ideology. He said that of course equilibrium price is determined by demand because this marginal utility to price ratio. We opened the lesson with that ratio again, the marginal utility to price optimizing consumption. So Jevons was like saying that of course it's demand that drives the equilibrium price, but Marshall, he was the smartest of them all. He said he used that analogy for demand and supply, the analogy with the scissors. He said it's pointless to argue whether it's an upper or under blade of the pair of scissors that cuts a piece of paper. It's just pointless. Demand and supply are factors acting simultaneously to determine the equilibrium price. You cannot just single out the demand and say that demand determines the equilibrium value of goods, right? That equilibrium price was previously referred to as a value, the theory of value, right? So it's pointless to discuss that it's demand that drives it, and it's just as well it's pointless to lay claims that it's a supply that determines an equilibrium price for produced goods. It's both, just you have the full comprehensive analysis will drive you to believe that it's an under and the upper blade of the scissors that is cutting the paper, right? That's the analogy he used. The analogy for the blades of scissors, the supply and the demand. I guess we are near the end of today's lesson, so just make sure you understand about the shifts and movements along the demand curve and also the supply curve. Understand that there's a notion of the market period of operations. It's a short term where the supply curve is fixed. It's a longer term time frame of analysis if you allow for flexibility in the shifts in the supply curve. And one thing we can discuss just to again to impress on you the vision of equilibrium, and that's a very powerful vision in market analysis. Let's discuss what is that sort of a thing. What is it? Partial equilibrium. Remember, we discussed that mathematical economists, what they decide about when they analyze markets is whether there's equilibria, some equilibrium point, whether it's a single or multiple points like here, that here. If we have multiple points, which one is stable, if such point of stability exists, or all points are just points and there is no intrinsic mechanism operating on the market using these points to be real equilibrium points, meaning that all those points are just fake ones because there's no mechanism ensuring the market operates and settles down upon them. What is a partial equilibrium? Now I think it's important to discuss that. When we discuss a market, just an individual market, like in these examples, when we did them, sometimes we are discussing just one market. For example, that market for carrots, right? There was just one market, and then there's something happening outside of that market. The size of population is increasing, and so this shifts the demand curve upwards. just one market is subject to analysis. This is called the partial equilibrium analysis when you just take one market in isolation, the carrots market, right? And abstract from all other markets out there. The equilibrium analysis that you do are demand curve shifts upwards. There's new equilibrium point. It's a partial equilibrium analysis. A partial equilibrium analysis. So that's the meaning of the partial equilibrium analysis when you analyze just a single market. But we also had some examples, especially when we discussed the market for oil, the market for buying petrol cars, and the market for buying electric cars. Actually, at that point in time, we actually considered three markets intertwined, affiliated, associated with each other. They were intertwined. There was an oil market that is not portrayed here in the background, right? That affected the equilibrium for the market for petrol vehicles. Remember that example from 1 hour back? That affected the market for petrol vehicles, petrol cars. The demand shifted downwards. At that price, at every price, less was supplied in consequence of high fuel costs. But that also had ramifications, repercussions on the market for electric cars, and the demand curve shifted upwards in that instance. If you remember, it was the upward shift. So what is happening? We're analyzing how a change in one particular market for oil affected equilibria on all the related and associated markets down the line or up the line. From oil, the repercussions for the equilibrium on the petrol car market was discussed. That had repercussions for the electric car market. That new equilibrium point settles there on the electric car market. Maybe that new equilibrium on the electric car market will have repercussions on some force market, and that repercussion will also affect again the petrol cars market, affecting again the repercussion for the oil market, right? So when you have this vision of different multiple markets, right? Multiple markets in association with each other, something happens here for oil that has a knock-on effect on the petrol car market and that market, some other market. Then you have a loop. That market affects something back here. So I have this vision of constantly shifting interplay of market forces, constantly shifting equilibrium points. New equilibrium point on that market shifts an equilibrium point on that market. The partial equilibrium moves here. Then it moves, affects that market affects the original market. They have the interplay of equilibrium points, the equilibria affecting each other in a game of it's a wild game of multiple shifts and repercussions. It's a wild game of that, and that's a thing called the general equilibrium analysis. You analyze the equilibrium points for all the markets out there in general. So that's why it's called the general equilibrium analysis. So if you analyze an equilibrium point on the market in isolation, abstracting from all other markets out there, it's a partial equilibrium analysis. If you analyze, if you have that vision for all sorts of markets moving, shifting their equilibrium in unison, one after another, then back to the first one, that vision of multiple repercussions, right, in a loop going back up and down, then it's a general equilibrium analysis. The general equilibrium analysis. And mathematical economists, they do that, they analyze markets in association with other markets for substitutes, complements, and some other markets down the line. Market for capital in association with market for example, for money, in association with the market for oil. That is a general equilibrium analysis. See how difficult it can get with all the sorts of equilibrium analysis. We started with something very simple in the past week, and now we move to something very grand. It's some grand vision of multiple markets with shifting equilibrium points interrelated to each other. It's a very grand vision. that general equilibrium vision, and that vision is brought to you with this idea of the demand curve and the supply curve. This idea of the demand curve and supply curve was introduced to you by that guy Antoine Cournot, right, and popularized by Alfred Marshall. And here we have the great grand edifice of economics being built on that foundation of the demand and supply curves. Just to summarize, okay, over this week and the previous one, we discussed normal goods and inferior goods. The normal good is the one having a normal downward sloping demand curve. The inferior one is the one with the income effect coming into action. The potato after the Irish famine was an inferior good. Its price being less, the consumption for the potatoes didn't increase. Rather, it's a consumption for meat that was affected. Again, the vision of general equilibrium, right? The vision for general equilibrium comes into play here. It's a price in one market changing, but this has repercussions, effects for the consumption not of potatoes but of meat, that of meat. Something on the market for potatoes develops, but this percolates, the effect percolates down to the market for meat, and that's in association with the income effect that we discussed. Then we have the association. The first one, that one was between normal and inferior goods. The second association we discussed today actually was between complementary goods and the substitutes. Remember the iPhones and Androids, right? The iPhones and Androids are substitutes, right? But iPhones and their cover and their protective glass are complements. The phone and its accessories, the cover and the protective glass, are complements. The what was that? The milk and the cornflakes were complements, but electric cars and petrol cars were substitutes. The iPhones and Samsungs were the substitutes. If the demand for, let's say, in association with that substitution and complementarity, if the demand for one good, let's say, we are discussing that situation for complements, if the demand for iPhones increases, right, then the demand for their covers and their protective glasses will also follow suit and increase, right? One demand causes the other to increase. That's for complements. And for substitutes, it's the other way around. If the demand for one thing increases, let's say, that's like for the cars, for the electric and the petrol ones. The demand for the petrol ones decreased, right? Went down. And because the demand is like shifts here, right? It shifts from one substitute to another. The demand for petrol cars went down, but it was the demand for the electric cars that increased. One for petrol cars went down, but one for the electric cars increased. So if the price for one substitute item increases and demand drops down, then the demand for the substitute good increases. Price for one substitute good, the first one increases its demand. The demand for the declines, but it's then the turn for the demand for the substitute good to increase, right? And if you analyze market in terms of demand curves and assuming the supply curves are fixed, then you're operating in the short term. But if you allow for some flexibility in the supply curves, then you're operating over the longer term period of market operations. According to Marshall, he introduced a distinction between the short-term periods of market operation and the long-term period of market operation in relation to how much flexibility you are allowing for the supply curve to shift and generate the changes in that curve. In teaching week 1, we also introduced to use distinction between capital goods and just perishable goods, right? Capital goods what are your cars, vehicles, productive plant, equipment. These are capital goods lasting for at least longer than 1 year. Longer than 1 year. Their utility derives over the period of time, usually longer than 1 year. That's why this is called the capital goods. But your cars, right? Actually, it's your personal car. It's a consumer durable. Consumer durable, not exactly the perishable good, not exactly the capital good. If you're discussing washing machines, even the vehicles like Nexus and Sparks, right? We are discussing not exactly the capital good, but something in between called the consumer durables. But if that Nexi or Spark are on duty as a taxi vehicle, that vehicle is capitalized on the balance sheet of a taxi company, and in terms of macroeconomic portrayal of the situation, yes, Nexus on taxi duty become your capital good, not a consumer durable anymore, but it's a capital good capitalized on the balance sheet of the taxi company. So we know that there's a distinction between perishable goods and capital goods. The stock of capital goods is your factor of production that allows your economy to develop, right? And in between perishable goods and the capital goods, we have some interim categories of consumer durables. And one word also used in association with goods, fungible goods. Fungible goods are goods which are produced in mass, like say chips, right? Chips, right? They're produced in the same identical packaging at the rate of thousands per day, right? But let's say books, right? These days, if you print one book, you print books in a very small print runs, and I guess this is not the case of fungible book because one book is different from another. So it's non-fungible good. Fungible good are your like mass-produced goods and also food staples like rice. It's a fungible good. 1 kg of rice is same as any other kg of rice. Coke, right? The standard issue for Coke, the Coca-Cola thing, right? It's a fungible good because it's mass-produced. Every other bottle is same as the other one. So it's a fungible good, same as the other of the same brand. The Pepsi Cola bottle is a fungible good, but I guess like books, right? They are now not mass-produced anymore, like printed in small quantities. So this is not your fungible good. Okay, so we're now learning new words with you. Fungible. What is fungible? Meaning same as the other, right? Same as the other. So we're learning things together. And thank you for your attention. We finished an important department of economics, introducing to you the demand and supply curves. After 1 week, we'll focus more on supply curves. But I think as far as the introduction and justification of the demand curves goes, we are done with that. We'll do some tutorials in the next week, but the idea is already out there, introduced to you for your use and perception. In our analysis, as we moved along, we assumed that our curves are continuous, smooth, right? Our production and consumption is a smooth, continuous process. Our curves with respect to P and Q are the smooth and monotonous curves. But it's in a sense a simplification because if you remember when we discussed the market for the electronic market for gold in the past week, our supply schedule that can be also presented as a supply curve was as crazy as that. It was like something maybe a little bit downward sloping, but uneven, right? And jagged. And our demand, so it was our demand curve, right? The D curve, and our supply curve was also actually it has non-monotonous and disruptive properties. It was a discontinuous one, so our supply curve went like maybe also upward sloping, but it went like that. But and only in that area we had some point of like area where you match demand and supply, point of negotiation, right? So in reality, things are not as smooth and continuous as we make them to be. They can be something as crazy as that for like what we saw for the gold market, right? And they can be just as crazy as that, right? With multiple equilibrium points, no equilibrium point at all possible, right? If you have a very big spread between demand and supply in the gold market, right? A very big spread like your demand shifts here, right, and your supply goes up, you have a very big spread developing between the demand and the supply, and the market can break down, or just there can be disruption to the market. It's a very thin market that can develop. All permutation possibilities are possible. Things are not as easy as they look, but well, at least we have some very powerful tool to analyze economic processes, the markets, right? This the tool is called the demand curve and also the supply curve. We'll continue on supply curves after 1 week, I guess. In the next week, we'll discuss how to analyze demand curves with how to measure them with derivatives and that thing that economists are using, the elasticities. The derivatives and elasticities is something we'll discuss with you the next week. Thank you for your attention. Bye bye.